This is a video for AQA Further Pure Mathematics. This is complex numbers, section 1.3, where we're considering multiplying of complex numbers. So when multiplying two complex numbers together, we write them in brackets and then expand the brackets as we would do in any other situation where we've got two brackets multiplied together. So I quite often use the acronym FOIL for first, outside, inside, last. So here we've got the first term, 2 multiplied by 4 being 8. The outside terms giving us minus 2 multiplied by I. The inside term, 3i multiplied by 4 giving 12i. And then finally, the end, we get negative 3 multiplied by I squared. Now what we need to then remember is that I squared is equal to negative 1. So this then becomes 8 plus 10i, and then we've got negative 3 multiplied by negative 1, which is plus 3. So in total, 8 plus 3, being the real part, is 11, and then plus 10i. Right, noticing that then we got I squared being negative 1, and this is going to happen a lot when you're doing multiplication of complex numbers. So remember that I squared is equal to negative 1. We could also consider then what is I cubed. Well, of course, if we know that I squared is equal to negative 1, then I cubed is I squared multiplied by I. So therefore that must be equal to negative I. And I to the power 4, well, I to the power 4 we could consider as being I squared multiplied by I squared. So it's negative 1 multiplied by negative 1, which of course is plus 1. Well, to consider higher powers, we simply write out the bracket this time 3 times. So we've got the product of the 3 brackets and consider them as a pair to start off with. So if we look at the first 2, then we will get the outside, the first term's giving you 4, the outside term 2i, the inside term 2i, so in total 4i, and then the last term I squared. So that we can then simplify the I squared being minus 1, because therefore a total of 3 plus 4i. And then we repeat the FOIL procedure again. The first term, 3 multiplied by 2, outside 3i, inside 8i, and then plus 4i squared. Looking at that again, we've got I squared is negative 1, and so therefore that's minus 4. So we get a total of 6, 11i, and minus 4, so that the number is 2 plus 11i. Well, here's an example of a sort of question that you might face in an exam. Here we've got a complex number z, which is 2 minus root 3i, and we're asked to find z plus z squared in the form a plus b root 3i. Well, first of all then I'm going to work out what z squared is. So do remember that you need to multiply z by itself and not just square the real and the imaginary parts. So it's 2 minus root 3i multiplied by 2 minus root 3i, again using FOIL. The first term, 2 multiplied by 2, is 4. Then we get the outside term is equal to 2 multiplied by root 3i, so sorry, negative 2 root 3i. The inside term is also negative 2 root 3i. And then finally we've got negative root 3i all squared. So for total for that then is 4, then minus 4 root 3i, and then this final term, the negative root 3 squared is 3, and then I squared, so this is plus 3i squared, which of course is negative 3. So we get 4 minus 3 is 1, and then minus 4 root 3i. So that's z squared. Now we're asked to find z plus z squared. So z plus z squared is equal to 2 minus root 3i, and then plus 1 minus 4 root 3i. Adding the two real parts together, 2 plus 1 equal to 3, and then we've got minus 1 times root 3 and minus 4 root 3, so in total minus 5 root 3i. If you'd like to do some more investigation of multiplying complex numbers, there's a GeoGebra file that you can look at. This also, as well as just looking at the multiplication of the numbers, considers the effect of these on an Argand diagram. Now, Argand diagrams we will meet in a later video, so you may wish to delay looking at it until you have studied Argand diagrams. That's the end of this video. In the next video, section 1.4, we'll be looking at dividing of complex numbers.